Alright, in this example it tells us to find the vertex of f of x equals negative x squared plus 6x minus 8. We're going to find this using standard form. To help us identify the a, b's, and c's, I can write standard form right below it. Class, my a value is negative 1. My b value is 6. And my c value is negative 8. Partner B, tell partner A, what's the formula we need to find the vertex in standard form? What's our formula, Eduardo? So we just need the x part, so that'll be negative b over 2a. Now, you're correct in that we need the whole formula, but we're first going to find the x. Just like the previous formulas, a lot of students have struggles with the minus sign, so just leave the minus sign to the very end. Don't touch it. Class, what's your b value? And your a value? 2 times negative 1 is? 6 divided by negative 2 is? And what's the opposite of negative 3? X is equal to a positive 3. Alright, so we have the x-coordinate. Now we need to get a y-coordinate. To get a y-coordinate, we're just basically going to substitute that into our function, and we're going to evaluate. F of x, I'm not going to write the x squared, that's a negative x squared, plus 6 times x minus 8. And instead of writing a x here, what are we going to write, class?
3.
Let's put in a 3. So I have f of 3. If you don't remember, this is just basically a fancy way of saying we're putting in a 3 for every x value. So I have 3 squared, and the opposite of that, plus 6 times 3 minus 8. Class, should I do the exponent or the subtraction sign? PEMDAS tells you to use which one first? Exponents. So 3 squared is 9. 6 times 3 is minus 8. So here I have negative 9 plus 18 is 9, and 9 minus 8 is 1. F of 3 equals 1. This is our vertex. Let's label that, vertex. Let's give ourselves a visual of what's happening here. Just a really quick graph. Zoom out. See this? Let's use all of our puzzle pieces. In standard form, I have a c value that's negative 8. 2, 4, 6, 8. This represents my y-intercept. Here, a x equals 3 is a axis of symmetry. So let's graph that in yellow. My blue, right 3, up 1 is my vertex. Notice how the vertex will always be on the axis of symmetry. I have an A value that's negative, so the graph opens down. And if you recognize quadratics, they are symmetrical. What does that mean? Here I went left 3, down 8. Sorry, 9. Left 3, down 9. And so my graph's going to look something like this. With my glittery pen. Okay? So the big idea here is this. From standard form, we can find the axis of symmetry and the vertex. In this case, the vertex is a minimum.